Hi again. All right, so now we're going to move on to division. Division is the opposite of multiplication. So if in multiplication we add exponents, in division we subtract exponents, okay? So one way of looking at these, I'm going to show you two different ways of looking at them. One way of looking at division is that we subtract the exponents on the same base. Okay, coefficients would still divide. So for example 1, I'm going to do the problem two ways. One way is I'm going to subtract the exponents. Be careful when you're subtracting. It's 10 minus negative 5, right? So it really becomes 10 plus 5. So this can be simplified to 10 plus 5 is 15. This is x to the 15th power. Another way of looking at the problem is that x to the 10th is being divided by x to the negative 5th. I'm doing this in blue over here. And you can look at it as the way we've been simplifying, which is if you have a negative exponent in the denominator, you're taking its reciprocal, so you're flipping it up to the numerator as x to the 5th. And then now that it's a positive 5th power, it's going to multiply by x to the 10th, which means you add the exponents, 10 plus 5, x to the 15th. So you can see it gives you the same answer, it's just a slightly different approach. Okay? So in example 2, you can go back and forth using both ways. I tend to use the second method a little bit more in most situations, but sometimes I use the first one. So you'll see me kind of going back and forth. In the next example, examples like these, I tend to use the second method of like taking the reciprocal and moving the terms, or the parts of the terms. So in the first part, I'm now looking at x's. Oh, I need highlighter, sorry. I'm looking at the x's with the x's. If they both have positive exponents, I don't need to really do anything. I'm just going to subtract. So 6 minus 2, I'm going to subtract those exponents, gives me x to the 4th. Since it's a positive power, I'm putting it in the numerator. Okay, if it had been x to the negative 4th, I would have put it in the denominator as x to the 4th, because then that's 1 over x to the 4th. Okay, now I'm going to the y's. So for the y's, I'm going to highlight those in green. Okay, again, you can use either method. You could subtract. Negative 1 minus 4 is negative 5. Or you could take the one with the negative exponent and move it down as y to the 1st. And now it's going to add, when you multiply, y to the 5th in the denominator. So I have y to the 5th in the denominator. Okay, because remember, it was y to the negative 5th. So that goes into the denominator as y to the 5th. And then for the z's, I'm going to highlight those in yellow. I have both of them with negative exponents. So I tend to then say, okay, well then this one flips up as z to the 4th, and this one goes down as z to the 8th. Now that I have positive exponents, I can just subtract. 4 minus 8 is negative 4, so I have more z's in the denominator. It's z to the 4th in the denominator. Okay? Again, if you had just subtracted from the beginning, you may prefer that method. If you're subtracting from the beginning, you're subtracting negative 8 minus negative 4, which is really negative 8 plus 4, which tells you it's z to the negative 4th, which again goes in the denominator because it's 1 over z to the 4th. All right, in example 3, I've added a little bit of complexity by just putting some coefficients there. So you have coefficients, negative 10 and positive 18. These would divide if the denominator divided evenly into the numerator. Okay, so I'm going to write here divide if possible. If not, you simplify the fraction. So, or simplify fraction. So 10/18 is a fraction. They're both divisible by 2, right? So I have negative 5 over 9. Now I'm going on to the a's. I'm going to subtract the exponents. I'm going to use the subtraction method this time. So 4 minus negative 2. 4 minus negative 2 is 4 plus 2, which is 6. I have a positive 6th power, so I'm going a to the 6th in the numerator. Okay, then I'm going on to the b's. For the b's, I'm subtracting. 6 minus 12 is negative 6. So I have b to the negative 6th, so it goes in the denominator as b to the 6th, because it's 1 over. And then I'm going to subtract the c exponents. So I'm going to subtract negative 2 minus negative 10. Negative 2 minus negative 10 is negative 2 plus 10, which is 8. I have a to the positive 8th power. Sorry, c to the positive 8th power, so it goes in the numerator. And there's my final answer. Okay, so I'm subtracting these exponents. Okay, moving on. If you have an entire fraction, in example 4, you have an entire fraction that's being raised to a negative power. Okay, so this is a fraction, which is division, being raised to a negative exponent. The way I do these is I take the exponent apart. I first just use the negative in the exponent. Remember, a negative in the exponent means reciprocal. So the first thing I do is take the reciprocal of that fraction. So 2 over 5 becomes 5 over 2. Now I raise it to the positive third power. And that is just 5 times 5 times 5 over 2 times 2 times 2. So 5 to the third is 125, 2 to the third is 8, and that's it. Okay, I do that even as they become more and more complex. Example 5 is more complicated. I'm still going to start out the same way. I'm going to start with just the fact that this is a negative exponent. I'm going to take the reciprocal. So I'm going to literally just flip everything. 2b to the third goes to the numerator. 5a squared b goes to the denominator. Now it's to the positive fourth power. So now I'm just going to raise everything to the fourth power. So starting with the coefficients, 2 to the fourth. 2 times 2 times 2 times 2 is 16. And then I multiply the exponents, b to the 12th, over, I do the same thing with the 5. 5 to the fourth power, 5 to the fourth power is 625. And I multiply these exponents, so 2 times 4, I have a to the 8th, and 1 times 4, I have b to the 4th. Okay, now I have to notice that I have a b and a b that need to be simplified. Numerator and denominator that are dividing. So I'm going to subtract these exponents. So 12 minus 4 is 8. It's a positive 8th power, so it goes to the numerator. 16b to the 8th over 625 a to the 8th. Okay. The next one is a little more complicated also, but I need you to change the example actually. I need you to change the x here in the denominator to x to the negative fourth. There's a typo there before we start. Okay, so we're going to start again. I have a fraction to a negative exponent. I am going to first start with the negative in the exponent, meaning reciprocal. So I'm just going to flip this. I'm going to move 3x to the negative fourth y squared to the numerator. Notice that the negative in the fourth power stays. Okay, because I'm just taking the reciprocal right now, over 2x cubed yz, and now it's to the positive second power. Okay, now I'm just going to square everything. So 3 squared becomes 9. Multiply the exponents. Negative 4 times 2, I have x to the negative 8th. 2 times 2, I have y to the 4th. Denominator, 2 squared is 4. Multiply the exponents. 3 times 2 is 6. I have x to the 6th, and then y squared, z squared. And now I'm just going to go through simplifying same bases. So if I have x and x, I'm going to subtract these exponents, or you could move the x to the negative 8th down if you want. It'll become x to the 14th in the denominator. So if you wanted to, you could, if you feel more comfortable that way. I'm kind of switching methods here. So if this guy, take the reciprocal, goes down, x to the 8th, and then I add those, I have x to the 14th down here. If you just subtracted, negative 8 minus 6 is negative 14. It goes to the denominator. With the y's, I'm going to subtract 4 minus 2. I have just y to the second, and I don't have any other z's, so it stays in the denominator. And there we are. If you wanted to, some of you might be thinking to yourselves, can I simplify inside here first and then take the reciprocal? Absolutely. If you prefer doing it that way, you can always simplify in the fraction first, then take the reciprocal, then square. All right, we are going to stop there, everybody. Thank you. I'll see you later.